We are on section 5.4, dilations. Where, has anyone heard the word dilation before?
Yeah.
Yes, but not in a
Well, tell me, what are you thinking of dilation?
Eyeball.
When a baby comes out of you, they dilate you.
Yeah, okay, whenever you're in labor, you dilate. What does that mean?
Your
dilating?
cervix opens up.
Yeah, your cervix gets bigger. Someone said your eyeballs dilate. What does it mean for your eyeballs to dilate?
Get bigger.
They can get bigger, or if it's really bright, they get smaller. So they get bigger when it's dark. That's because they're taking in more, trying to get in more light to see. But whenever it's light daytime, they get smaller because there's too much sun and you don't need as much light to see.
Okay.
So that's the same thing in geometry. A dilation is something getting bigger or something getting smaller. Okay. That's why it's called a dilation. All right, so you have a dilation that either enlarges or reduces a figure to make a similar figure. It's similar because it's the same shape, it's just not the same size. Before, all of our transformations kept it the same size and the same shape. Now it doesn't do that. Now it either makes it bigger or makes it smaller, but it has the same shape, just not the same size. So here we had the blue triangle PQR, and then it was dilated, it was made bigger into triangle P prime, Q prime, R prime. This would be an enlargement. Something that would happen here would be like, let's say point C is the center of the dilation. That's like, for instance, if C was like a light, like a flashlight, and you're shining it on this triangle, and then triangle PQR is back in behind it, the shadow. That's the shadow. And notice it, it's bigger because of the angle. And then sometimes when you look at your shadow, it's smaller. Okay, so it depends on where the dilation's coming from, the center of the dilation's coming from. Whether or not it makes it bigger or smaller. All right, a reduction. A reduction is a dilation in which the scale factor K is between 0 and 1. So notice you're going to need to fill that in right there. It's between 0 and 1. So we're going to say you would say a dilation factor of 1/2. That means the new image is half the size of the pre-image. So between 0 and 1. So a half, 2/3, any number between 0 and 1. Okay? Yes.
You did not.
You need the notes? Okay.
I've been sitting here looking for them.
Sorry. Luckily, this is the first thing that you have to fill in. Okay, right. So right there on that first line where it says a reduction, you need to fill in where it says 0 and 1. It's between 0 and 1. Sorry. All right, so that's a reduction. When it's between 0 and 1, the scale factor will be between 0 and 1. An enlargement, the scale factor is going to be larger than 1. Okay? So something, if you multiply it by 2 or 3, or if you multiply it by 1.5, then it gets bigger. If you multiply it by less than 1, it gets smaller. It can also be written as a percentage. For instance, you can, like 1 would be 100%. If something is 100% of the size of something else, they're the same size. If it's less than 100%, it's smaller. Bigger than 100%, it's bigger. Thing I can think of is like when I'm zooming in on my computer and it does it by percentages, 100% standard. If I want it to zoom in, get bigger, I do greater than 100. If I want it to get smaller, so like zoom out, I'll make it less than 100. But it can be written as a fraction, a decimal, or a percent. So you can use any of those numbers. All right, so what if we had to find the scale factor? Okay, so how to figure out the scale factor? It says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. Okay. All right, so how you do the scale factor is you do the size of the prime, the new image. Let me say new image instead of prime. You do the size of the new image divided by the size of the pre-image. All right, so the new image is the one that's with prime. So look at the length that's with prime. Notice from C to P prime is 12. So 12 would go on top. And then 8 would go on the bottom because from C to P is 8. So that would go on bottom. And then you can reduce that or divide that. You can do 12 divided by 8. What's that? Like 8, 9, 10, 11, 1.5? Will someone check that for me? Do 12 divided by 8, see if it's 1.5. Okay, so my scale factor is 1.5, and it says tell whether it's a reduction or an enlargement. Well, it's bigger than 1, so it'd be an enlargement, but you can also look at the picture. See how the original one is smaller than the new one? Well, you can see that it's an enlargement, that it got bigger. So we would put that it's an enlargement. All right, you'll notice on this next one, I whited out the numbers. So first thing you're going to need to do is fix the numbers. Okay. It says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. Okay. So this long line should be 30, and right here between these two should be 18. Okay. All right, so remember it's the new one over your pre-image. All right, so figure out which one's your new paper clip. Would it be the one with the P or the P prime? Grace, what would you say? Yeah, P prime. So P prime is the new one. So if you look from C to P prime, what is that length there, Lakin? From
the length?
Yeah, from C to P prime. Perfect. And then the pre-image was the original size of the paper clip. And what would be that length, Taylor?
30.
30. So we got 18 over 30. All right, so now do 18 divided by 30. And Nick, tell me what you get when you do 18 divided by 30.
0.6.
Okay, and is it just 0.6 or are there any decimals behind it, like it's repeating or anything?
Now it's just 0.
Okay, awesome. So 0.6 is my scale factor, that's K. And now we need to figure out if that's an enlargement or a reduction. Abby, what would you say?
A reduction,
And why is it a reduction?
because it's not larger than 1.
Yeah, it's not bigger than 1. It's between 0 and 1. Now, whenever you're doing these numbers, if you want to leave it as a fraction, that's fine. You just got to make sure you reduce it. So, for instance, 18 over 30, I can reduce that by 6, and I would get 3/5. So, you could leave it as 3/5, or you could put it as 0.6. Or if you did percentage, it would be 60%. Either of those are fine. You can either do a decimal, a fraction, or a percent. All right, let's try this one. It says in a dilation, the length from C to P prime is 3, and the length from C to P is 12. Find the scale factor, then determine whether it's a reduction or an enlargement. So this time they didn't give us a picture, okay? But I do know that it's the new length over the pre-image. Okay? So which of these would be the new one and which one's the pre-image?
It is the new and top is the first.
How did you figure that out?
Because it's CP prime.
Yeah, this prime right here tells you that that's your image. That's your new one. Okay, so that one goes on top, so it's 3 over 12. All right, and then do 3 divided by 12. And Natalie Bolin, tell me what you get. You do 3 divided by 12.
1/4.
1/4, okay, so you can leave that as 1/4.
Or 0.25.
Yep, either of those will work. Either the 1/4 or the 0.25, either one's fine. And would you say that's a reduction or an enlargement?
Reduction.
Perfect. Okay. All right, what questions do you have for me so far? All right, Alright, so the next one's gonna be guided practice. This is one you're gonna do with your partner. First thing you'll need to do before you get in your groups is copy down the numbers. After you copy the numbers down, turn your desks to face each other. Natalie, you'll be working with Sydney and Abby. Alright, here's yours. So it says find the scale factor of the dilation and tell whether it's in a reduction or enlargement, and the numbers are 14 and 6. Alright, so go ahead, turn your desks to face each other.
This is confusing.
If you get a non-terminating decimal, you can round it to the nearest hundredth, which is 2 decimal places. Or you can just leave it as a fraction. Either one's
Oh, wait.
Yeah.
Now, I will tell you, if you're doing this on Big Ideas Math, they will not want you to round. They will want you to leave it as a fraction if you get something like that. But whenever you're doing it on a worksheet or a quiz, you're okay to go decimal.
But you put the questions on there, or you get find other names?
They already have they have the same questions that's in your book. And I just go through and select which questions I want. All right, if I can have your attention, please. On this one here, Nick, what did you and your partner get as the scale factor?
3/7.
3/7?
Yeah.
Okay. Abby, do you and your partners agree with that?
Yes.
Okay, what is that as a decimal for those that got a decimal?
0.43.
0.43. Okay, so that's your scale factor. That's your K. K stands for scale factor. And then, what did you and your group say that was on a reduction or an enlargement? Natalie, it's a reduction? Perfect. All right, what questions do you have for me on that one? All right, let's try the next one. Again, you're going to need to write down the missing numbers before you work it out, and then you're going to work it out with your partner. From point C to point P is 15, and from C to P prime is 9.
Alright, we got that here.
I got reduction 0.7.
All right, if I can have your attention, please. Brett, what did you and your partner get for the scale factor?
9 divided by 15 equals 0.6.
You said 9 over 15, and you said you got 0.6?
Yeah.
All right, do y'all agree with that? Yeah, you could have also had it as 3/5, either 3/5, 0.6, or you could have even had 60%. And Sydney, did your group say that that was a reduction or an enlargement?
Reduction.
Perfect. All right, what questions do you have about trying to find the scale factor, Nick?
On the first page, like the front of the paperclip one, that answer was 0.6 also, and you said it was an enlargement.
Did I?
Yeah.
No, it's a reduction.
Well, I did clear one.
The only enlargement is the first one. Nick, I think you just accidentally.
I think number 1, the very first one, the teacher model should have been an enlargement. The second one should have been a reduction. The third one should have been,
That's the only enlargement, the rest of them should be reduction.
I think enlargement
What's
right
the
now
only
too.
enlargement?
one's the only enlargement.
One's the only enlargement.
Okay, yeah, one's the only enlargement. All right, thank you for getting that. All right, go ahead and move your desk back so we can start on chunk 2. All right, so with all of the other transformations, you know, there were rules. For instance, the rule for vectors for translations, it was x to y is translated to x plus a, y plus b. With rotations and reflections, you either flipped them or you changed the signs. You multiplied them by -1, so it was like negative x comma y, or x comma negative y, or negative x negative y, negative y negative x. So those were all of those rules. With dilations, the coordinates, the rule is x to y is translated to k times x, k times y. So with a dilation, all you do is you take your two coordinates, your x and your y coordinate, and you multiply it by the scale factor. So that's what that means. You take your coordinates and multiply it by the scale factor to find your new image. So all you're doing here is multiplying. Before with translations, we added or subtracted. With rotations and reflections, we multiplied by -1 or we flipped them. With scale factor, all you do is with dilations, all you do is multiply it by the scale factor. Okay. All right, so show you an example to where it, you know, like what we've been doing in class with our transformations. All right, it says graph the triangle ABC with the vertices A21, B41, and C4, -1, and its image after a dilation with a scale factor of 2. All right, so first we graph the original triangle, ABC. Okay, so A is 2, 1, so that means you go to the right 2, up 1. B is 4, 1, and C is 4, -1. Okay, and then it says a scale factor of 2. Okay, scale factor of 2. So what this means is you go through and multiply every single coordinate by 2. So A prime, if I multiply those by 2, 2 times 2 is 4, and 1 times 2 is 2. For B prime, 4 times 2 is 8, 1 times 2 is 2. And for C prime, 4 times 2 is 2, -1 times 2 is -2. Okay. And then you just plot these new coordinates. Yes, ma'am.
I don't think C prime is 2.
Yeah, sorry. 4 times 2 is 8. I don't know why I said 2. Thank you. There we go. 4 times 2 is 8. 2 times -1 is -2. All right, so A prime is 4, 2. And all of these dilations are going to be centered about the origin. So it's like the light, if you're thinking of a shadow, it's like the flashlight is there at 0, 0, and it's shining on the pre-image and giving your new image. So let's see, A prime was 4, 2. B prime was 8, 2. And C prime is 8, -2. And then you connect those. Guys, don't forget, whenever you're doing these, whenever you're graphing a triangle or quadrilateral, you must connect the points when you're finished. Okay. All right, and there's your dilation. So now all we're doing is multiplying.
All right. So if it's like an enlargement or reduction on it?
Yes, same way if it's an enlargement or a reduction. Like if it was a reduction, it would say with a scale factor of 1/2, and then you just go through and multiply everything by 1/2. it says graph quadrilateral KLMN with vertices K. I'm going to have to pull that down because I can't see it. K is negative 3, 6, L is 0, 6, M is 3, 3, and N is negative 3, negative 3. And its image after a dilation with a scale factor of 1/3. Notice you're going to have to fill in that 1/3 on your paper. All right, so you're going to take first you're going to graph the original, negative 3, 6. L is 0, 6, 3, 3, and negative 3, negative 3, negative 3. Now use your scale factor of 1/3, and you would go through and multiply each of these numbers by 1/3. So K prime, negative 3, 6. What would be those new coordinates if I multiplied them each by 1/3, Abby?
Negative 1, 2.
Oh, perfect, negative 1, 2. And then you got to do L prime, which is 0, 6. So you got to multiply each of those by 1/3. Natalie Pruitt, what did you get with that one?
Just 0.
0. And what about the Y value? 0, 2. Awesome. All right, then we got M prime, which is 3, 3. Lathan, what did you get for those new coordinates?
1, 1.
Awesome. And then you got N prime, which is negative 3, negative 3. So N prime would be what, Taylor?
-1, -1.
Perfect. Okay, so K is negative 1, 2. So to the left 1, up 2. L is 0, 2. Or sorry, L prime. M prime is 1, 1. And N prime is negative 1, negative 1. What questions do you have for me? All right, here's the next one. Graph triangle PQR and its image after a dilation with a scale factor K. All right, notice that K is 4. So you first want to start off by graphing the original. Okay, so negative 2, negative 1 would be to the left 2 and down 1. Negative 1, 0 would be to the left 1. And 0, negative 1 would be there down to negative 1 right there. Okay. And then it says it has a scale factor of 4. All right, Maddie, what is that? What is this K equals 4? What am I going to do with that 4?
Multiply the 4 by each quarter.
Yeah, multiply this 4 by everything here. So what do I get for P prime, Abby?
Negative 8, negative 4.
Perfect. What about Q prime, Grace?
Negative 4, 0.
And what about R prime, Natalie Willing? -1 times 4.
Oh, we're kind of negative 4.
Perfect. Alright, so P prime is -8, -4. Q prime is -4, 0. And R prime is 0, -4. There you go. Alright, what questions do you have for me so far? Alright, so the next two you're going to do with your partner. First, you're going to have to write down what the scale factor is. Well, did it give you the coordinates on these, or do you have to write the coordinates? Okay, so I'll give you a second to write the coordinates down and the new scale factor, which is -0.4. So notice this time your scale factor is a negative. Wonder what that's going to do. After you get it written down, you can go ahead and turn your desk to face your partner and work it out together. Alright, if I can have your attention, please. For P prime, I got -2, 2. Q prime, I got 0, 2. And R prime, I got -2, -2. Is that the same thing you got? Yeah. And then over here, I graphed it. So the 0.4, was that an enlargement or a reduction? It was a reduction. What did that negative do to it?
Right.
Yeah, I rotated it, flipped it, so it was, pretty much going this way, and now it's going that way, depending on how you look at it. So a negative sign, just like before, whenever you multiply it by -1, you're doing the same thing you did before. You're either rotating it or reflecting it. And that's what the negative does, and we already, like I said, we already knew that from previously. All right, here's the next one. Try this one. Don't forget to fill in the coordinates first. Alright, if I can have your attention, please. For x prime, I got 6, -3. Y prime, I got -6, -6. And z prime, I got 3, 6. Is that the same thing you got? Okay. And then here is my picture. X, Y, Z is smaller than x prime, Y prime, Z prime. Okay, because it was an enlargement. Alright, what questions do you have for me? Yes, this will be page 25 of your notes, 5.4 dilations. This is the last section. Stay with your partner. This is the last section of chapter 5. So you will be having a chapter, you'll have your quiz at the beginning of next week, and then you'll have a chapter 5 test at the end of next week. What we're going to go ahead and do now, once you get your table of contents filled out, use your notes and go ahead and turn to page 120 in your student journal.
Wait, probably not gonna write it in there.
120. Alright, I want you to do numbers 1, 2, and 3 on 120, but I want you to change them a little bit. You see how it says after the similarity transformation, and they have two different types of transformations, like a translation and a dilation, a reflection and a dilation, and a rotation and a dilation. I want you to mark out the one that's not a dilation. So number 1, mark out the translation. Only graph the original, and then only do the dilation. Notice it says 3x, 3y. So what are you going to do with the x and y coordinates to do the dilation? Multiply them by 3. And then on number 2, mark out the reflection. And 1/4 x and 1/4 y means multiply them by 1/4. And then on number 3, mark out the 90-degree rotation. Don't do that. And then notice it says the dilation is 2/3 times x, 2/3 times y. Okay. You have about 8 minutes to work on this. Whatever you don't finish will be homework, but you're only doing numbers 1, 2, and 3. You can work with your partner. Let me know if you have any questions. The reflection, that's not dilation. Yeah, I'll only do dilations, yes, sir.